Okay, so let's start. My name is Jakub Kubrynski, and I will be talking about metrics in the architecture. So the architecture is technical knowledge, and the problem is that often we treat it as some humane, and we are not just using any particular numbers or things that we are sure about to describe the architecture, but we are often like doing it on our gut feeling or something. I feel that we should go that way, or I feel we should use microservices. I feel we should, I don't know, automate the database migrations, but we don't know it for sure. So now I will try to explain why it's important. So a few words about me. I've started coding when I was 6 in Fortran 77. Cool language. I do it professionally since 2004, so almost 14 years. I'm a trainer at the Bottega company when I run also trainings on the architecture. And often I see some questions, I see some problems, and now I want to share with you my feedback that I gathered through the last 5 years of doing the professional trainings. I'm also the member of the program committee of Devoxx, and I'm an open source contributor if I have some time to do that. I'm also co-founder of Devkiller. It's a platform for verifying the technical skills in recruitment, education, trainings, etc. And we do that based on the real-world problems. So we are not checking if you are able to invert the binary tree. We are checking if you are able to expose the REST API with, I don't know, Webflux and reactive Mongo support. We are also looking for the part-time remote Hello World developers, so people to help us create those tasks. Okay, so often at the trainings, when I begin a training on the architecture, I ask, what do you mean by the good architecture? Because everyone wants to have the best architecture in the project. But what does it mean? And of course, as you can imagine, as we are in IT, so everything is context dependent. So depending on the context, there are different answers to this question. So for some people working in some fast-growing companies, the scalable architecture is the most important stuff. Yeah, if you are working in some, I don't know, bank with old legacy application, you see the maintainability of this architecture as a key feature, key principle of this application. Okay, if you are working in some, I don't know, software house and you work for different customers, you see that, okay, so creating a tailored application, tailored architecture that fits the particular client requirements is the most important stuff that you can imagine. Still, for some people, the security of this application, of this architecture is important. For some, the flexibility, resilience, testability, okay? So these are the features that you can consider as a good architecture. The problem here is that when I ask, okay, so what do you mean by the testable architecture? What are the, I don't know, the principles of the testable architecture? And that's the problem, because no one knows, in fact. Okay, I want my architecture to be flexible. What does it mean? How can you say that this architecture is flexible and this one is not? Is there any scale of flexibility? Is there any scale of resilience of the architecture? And if there is no scale, how can you say that this architecture is more resilient than this one? If there is no scale, there are no numbers. So it's just a rough guess, okay? And the other problem is that we often miss one really important feature of the architecture, that it should be implementable. I can create a brilliant architecture that integrates in a transactional way between FTP server, HTTP application, and a hard drive. And it looks great on the whiteboard. However, you cannot implement it, okay? So the biggest issue with the architecture, and the most important feature of the architecture, is that it should be implementable. And why do we create not implementable architecture? Because of the architects, right? I've attended a great talk by Ted Neward, who said at the beginning, like, if you are flying a plane, you are going to holiday or something else. During the taxi, the flight attendees are describing the security procedures. And they're saying that in case of drops of the pressure, there will be mask that will fall down. You need to put the mask on. Okay, if you are traveling with a kid, then put the mask on you, then on the kid. Yeah, if you are traveling with 2 kids, then you need to choose which one you love better, and then put the mask on, and that's why it works. And the question is, why do we need masks? Okay, we need masks because there's a problem with the oxygen on high altitudes, right? And what are the issues when the brain is not getting as much oxygen as it needs? Okay, there are many different stages and problems, but there are hallucinations. There is problem with excessive self-confidence, okay? Problems with reasoning, etc. Okay? That's all problems happen due to the lack of the oxygen. And the problem with meta-architects, so the architects from the ivory tower, is that they are operating on a similar altitude as the planes and then don't wear masks, okay? So the hallucinations, problems with reasoning, and excessive self-confidence, it's their daily basis. Okay, so that's the problem. And we know that the architecture is a structure of the system. It's the components, the relations between those components, etc. Okay, but we need to put the science on. We need to put here some numbers. Okay, I'm able to put numbers on my code base. I know how I can measure the, I don't know, complexity of the code, number of the lines, code coverage, etc. Everything can be measured, right? On a code level. So why we are not using the same on the architecture level? And the question is, if I'm not an architect, I'm just a normal developer, should I still think about the metrics in the architecture? And the answer is yes. Why? Because if we are talking about some kind of the architecture, we want to have a testable architecture in our project. For every single developer, this testable or testability can mean totally different thing. Okay? And if we'll use metrics, we'll describe the scale and numbers, we'll apply the numbers to this architecture, okay? Then we get a clean communication without communication gaps. Because often we assume that if we are talking about resilient application, everyone sees the resilience architecture the same way, and it's not true. If I'm asking what does testable architecture means, okay, and I have 10 people on the workshop, there are 10 different definitions of the testable architecture. That's the problem. If we'll put the numbers, then the problem will go away, okay? No communication gap anymore. So we tried to do that, and it was much harder than we expected. But we found a guy called Tom Gilmour. He is, I think, the father of this approach to the software development. He's the author of the Evolutionary Project Management and the author of the great book Competitive Engineering. If you didn't read it, just read it. And it was 2 days when he was repeating all the time, quantify and write down the scale. We said, okay, Tom, we want to have a great office. Cool. So can you put the scale on? Said, no, because we are talking about the great office. I know, what's the scale of the great office? Okay, so that's the problem. But the nice thing is that we did put the scale on a great office. So you can scale everything, but usually when you have problems with scaling, it means that you are not sure what you exactly want to achieve. Okay, so these are the 2 most important things. If you can quantify the requirement and put the scale on this requirement, then it's really, really good. So what are the most important attributes of the metrics? So first thing is the metric should be quantified. Okay, that's the most important thing. Then it should be measurable. If you cannot measure the particular value of the metric, so why do we need numbers? I have numbers, but I cannot verify if those numbers are real, if they are working, okay? And the third one, which is also important, it should be credible, okay? I have this metric, but what's the credibility of this metric? Is it 0 because I just guessed that it should be 5, okay? Or 6, because 6 is as good number as 8, as 4, just random number. So the credibility of this matrix is equal to 0. Or maybe the credibility is 1, because I've did it in the recent project and it worked exactly the way I think. Easy. Okay. This is a horse. Okay? Do you think that it's easy to draw such horse? Who could just come here and draw this course right now? Okay, yes, it's extremely complicated. You need to have particular skills and experience to draw such horse, okay? And do you think that applying architecture metrics on a distributed system is easier than drawing this horse or harder? Yeah, it's hard, okay? So what's the most important for you to know is that you shouldn't start drawing such horse if you cannot draw, okay? I can draw such horse. It's not a donkey, it's a horse, okay? But, okay, it's not as great as this one on the left, but it's good enough for communicating reasons, okay? If I will go to some country where they don't speak Polish, they don't speak English, they don't speak German, I will still be able to say that I need something like this to travel. They say, hey, here you are, yes? Because it's good enough to describe it. And the same applies to the metrics in the architecture. Before you will try to do, or you will start doing some very, very complex metrics, start with the simplest ones, okay? Just to start thinking about those metrics and try to align your way of development, your development style, or development team, your planning, grooming, etc., to metrics, okay? And the simplest architecture metric I can imagine is that I will say, I want to have a fast builds. Okay, great. But for everyone, fast builds can mean totally different thing. If I'm used to work with microservices, and my service compiles more than 2 minutes, I'm saying, it's so long, okay? On the other hand, if you're working with some legacy application and it's 45 minutes compilation time, then you say, oh, much better than yesterday, it was 60 minutes, right? So it's totally different. So we need to put the scale and say that, okay, so fast build means that the total build time of the service with tests is equal to, I don't know, 2 minutes. And the total build time of the library without tests is 30 seconds, okay? And that's the metric. That's the simplest metric you can imagine. That's the simplest metric to measure because you just go to Jenkins, you click on the build trend, okay? And you get the metrics value. And you know that, okay, we want to keep our builds fast, which means if my build is taking now 2 minutes, and you're saying, okay, so let's add some super feature to generate the documentation or something like that, it would be cool. I would say, okay, how long does it take? 30 seconds. Okay, we cannot do that because our build time will exceed the particular metric. So what we can do now is to try to speed up the build by, I don't know, maybe removing some legacy tests, maybe parallelizing the tests, just to get the space, those 30 seconds that we could fill with this new documentation. Okay, but I have metrics, so I'm thinking about that when planning any changes. I can do the same to the pipelines. I want to have fast pipelines, which means the total runtime of successful service pipeline should be less than 15 minutes. Okay? What's the current value? 10 minutes. Okay. So you say, okay, so let's check if we can roll back the system automatically. Is the automatic rollback, are we able to test the automatic rollback? Of course we are. How long does it take? 2 minutes. So we are good. We are at 10 minutes. We have 15 minutes limit, so we can add this without any issues, okay? But if you are on the 15 minutes and you want to do something like this, then we say, no, we cannot do that. Maybe we can still parallelize the tests, remove maybe some environment. Maybe we can avoid the rolling update on staging environment and leave the rolling update just for production. That will speed up our build, and we'll see what's the speed up, okay? I will get the number, the particular number to do that. Okay, So let's try to do something more complex. Backup time. Good metric. I will set that the metric is total backup time for a given component. It's my metric. And currently, it's 10 minutes, and my goal is not to exceed 20 minutes. Something is wrong here. Why the goal, so something I'm trying to achieve, is worse than the current situation? I know it's because the data will grow up. There will be more and more data, so obviously the backup will take more time. Okay, but how can I now try to align with this metric? And the problem is that it's not a metric. It's a technical debt. Okay? And it's not a goal. It's my limit. I don't want to exceed 20 minutes, but if I will stay at 10 minutes, then it's great. Okay? The metric, the quality metric, means that you want to do everything to reach the goal. And here, I'm trying to do everything to not reach the goal. That's the reason, okay? So that's the technical debt metric. I need still some efficiency metric, and I define it as a backup efficiency for a given component, a given volume. And I said, okay, so now to back up the 10 gigabytes of data, I need to spend 10 minutes on that. And I want my goal to be 5 minutes. So I need to speed up my backup time twice to be able to stay with this particular technical debt not exceeding 20 minutes, because I know that my data will grow 4 times. Okay? So that's the idea. Of course, if you can go from those 5 minutes to 2 minutes, then it's still great. But my goal is 5 minutes. That's the most important stuff for me. Okay? So, let's move on. Testability. That's the really nice thing. So, for me, testability means that the total execution time of all, let's say, unit tests is 30 seconds. Why is testability? Because for me, if it takes more, then people start to ignore tests. If people are ignoring tests, they are not testing their software, so it's not testable. Okay? That's my idea. It's still easy to measure. There are no problems with applying such metrics. Okay? But of course, obviously, it's not covering all the stuff that's here. So, let's say that I want to also track the number of some bugs. Let's say that the total number of critical performance bugs on production is also my testability metric. But there is a simple asterisk mark. Do you have any idea why this metric is marked with this one? Because it's the first metric that is not unambiguous. Okay? It's the first metric I can try to, let's say, fix or correct or keep by talking to people. Hey, it's not a bug, it's a change request. Please, don't put it into Jira as bug, because it will ruin my metrics. Okay? It's not how it should work. Because metrics, what we cover later, are blameless. Okay? The idea of the metric is not to just, I don't know, blame people. It's to help me drive my architecture. Okay? If I have 10 performance bugs every month on production, okay, it can mean two things. My team is really, really poor, let's say. We don't know how to do good software. And the second one is that procedures used by the company I work for are not perfect. There are a lot of potential problems, and there are a lot of issues that allow me to introduce the performance problems, performance issues, performance bugs to production, okay? So I need to redesign my process. I need to redesign my architecture, my pipelines, okay, to prevent such problems. And that's why I use those metrics. They are not for blame the team that you are introducing 10 performance bugs per month to production. They are to think about what can we as a team, as a company, as a, I don't know, a vendor, do to not introduce those bugs, to fix those bugs before they will enter the production. Okay, so that's the idea of the metrics. Okay, another important metric that we use at our company is the metric that describes the number of Devxx per day per developer. Okay, why it's important? Because it describes something we call the developer experience. Okay, we had a problem in our company when we have some issues with DNS servers, and when I was using a VPN to connect to the stage environment, and I've opened like 10 SSH sessions, and then I needed to check something on production because there was some bug. I needed to check something. I needed to connect to the production VPN. So I did it. However, it wasn't working because our DNS server wasn't able to resolve hosts on two different environments at the same time. So I needed to disconnect this stage VPN, do something on production, then after a few minutes, get back to my job. And of course, all the 10 SSH windows, I needed to restart them, okay, because the connection was lost. And it was fuck, okay? And I did it usually twice per day, okay? So then we can also treat it as a metric, because if we'll go just with the applications metrics, we'll lose such important things, which is a developer experience, okay? It was the easiest metric to estimate. When you're estimating data, we said, okay, so VPN issues, everyone say twice per day, okay? So then we change it, and the problem gone away. So that's the, also you can go with metrics everywhere you are going. Yesterday, there was great talk from the guy from Dynatrace, talking about the microservices and the quality of the microservices performance issues in distributed systems. And we also use it as a metric, because I can describe, for example, that the maximum number of collaborators of a single service can be limited to 3. So you can create a microservice, but for this microservice, you can use at most 3 different microservices. Okay? We can also say that if you are going a call to a single microservice, it shouldn't trigger more than 10 outgoing requests. Okay? And what's cool is that you can verify those metrics on production. Okay? We are even trying to introduce such feature to Spring Cloud Contract, where during the test, you can verify if you are not exceeding some number of collaborators. So if you are not using more than 3 steps of different services during the tests, or you are not invoking more than, I don't know, 10 requests for a given acceptance test or something like that, because some people use it for use consumer testing for that, okay? So it's still a great metric for your architecture, which describes the relations between the components, and it can be described with numbers, okay? Really easy numbers. What's also really nice feature of the metrics is that, let's say that we want to describe that we want to automate the database migrations, okay? That's the idea from the team. The team is saying, hey, we need to automate the database migrations. Okay, great. But why? Everyone does it. Great, but why? Okay? And now we try to describe it with particular numbers, because we want to limit the total number of database migration issues. We're migrating the database, and we forgot to add some column. We forgot to recalculate the index. We forgot to change the type of the column. Okay, so that's the first metric. Second, it takes a lot of time to migrate the schema. If we are doing a release, we need to get 15 or 30 minutes to apply all those changes because they are in different files, something like this. You can forget about it. So we want to automate this process. Great. It takes a lot of human power to migrate the database schema because we need to go to the DBA team, ask them to verify this, the migration script, then they need to be on the release on site, then need to apply it. Okay, great. So this is something that I want to achieve, right? Okay, great. But which metrics tells me that I need to automate the database migrations? Maybe I can just move to MongoDB, which have no schema, so there won't be schema issues, right? Okay, maybe it's a solution, maybe not, but I'm thinking about what I'm trying to achieve, and I'm thinking about the problem I'm trying to solve, not about the possible solution. Because automating the database migration, it's not a problem, it's a solution. I'm applying the solution, and I often don't know what's the root cause. What's the root problem that I'm trying to solve right now? And if I don't know what's the root problem, then why should I try to fix it? Okay? And if you use metrics and you try to describe the metric, okay, you try to put the scale, you are going deeper and deeper to understand the real problem. And I think that it's the most important feature of the metrics, okay? Because you start to ask questions. You ask why? Okay, but how much? Okay? It will help us a lot. Great. A lot, so what do you mean by a lot? 3 times, 5 times, 10%, 20%? What's the number? 30%. What's the credibility of this number? 0. Great. So let's do that. Okay? So the idea is that if you use metrics, you start thinking about the architecture, you are going deeper and deeper, and you are thinking if this solution will really work. What's the credibility of this solution? How much will we fix? How it applies to the other stuff, okay? Imagine how easier it is now to talk to the business and say, hey, dear business, we want to automate the database migration. Business say, why? And we say, okay, why? Please, because the total effort to migrate a database now is 5 man days, and after automating it will be 4 hours. Okay? Because we had 10 issues, release issues in the last 6 months, and then we'll have just 2 issues. Total time needed to migrate the database, now it's 30 minutes. We're able to do it in 10 minutes with automated scripts, so we can just shorten the maintenance window. Okay? That's the real value for the business. So if you are talking about the refactoring, then great, but describe this refactoring in numbers. Okay? The best number for business is always dollars. If you can describe it in dollars, like I can describe in dollars the last part. Okay, if I need 4 people to do something, and after the refactoring I will need just half the person, okay, that's the real saving of the business. They can buy a better car, I don't know, right? So, one more time, what's the difference between the metric and the KPI? Because often when you say to the business, hey, we want to introduce the metric, they say, great, we'll be able to use it for the salary, for the bonuses. No. Okay, so metrics are blameless. They are not to just set your salary, set your bonus. They are not used for settlements. It's the KPI. Okay, of course you can say that, okay, so use this metric as a KPI, but it's totally different way, totally different stuff. It's not related to driving architecture by metrics. I want to have metrics to keep my architecture aligned to some rules that I've applied. Okay? How it looks in practice. Let's say that I have some issue. It's an issue called Devoxx 759. I need to do something. And I have 3 different solutions to that problem. I can use some past database on AWS and on Azure. I can use MySQL, or I can use some new SQL, like a NuoDB database or something like that. And I'm checking 4 metrics. First is the portability. Let's say that I'm working on Azure, and how using or choosing particular solution will affect my portability. By portability, I mean how much time do I need to port this particular solution to other vendor provider. If I will use the PaaS database from Azure, and then I would like to go to AWS, I need to migrate the data to totally different solution. Okay, and I assume that it will take me 5 days because I need 5 days to create it on Azure. Okay, so I'll need it also 5 days to recreate it on AWS. For MySQL and NewSQL, which are provisioned by myself on virtual machines, there are no portability costs. Time to fix. Okay, if you are using some PaaS database, it means that you need some time to communicate with the cloud vendor to say that, hey, we have some issue, could you take a look at that, etc. So I assume that it will take me 30 more minutes to fix a bug if the bug will appear, okay? For MySQL, I already using MySQL, so it will be 0. And for NewSQL, it's still on my own, but I need 15 minutes to do that. Issues per month. So for PaaS data store, I assume that I will have 1 more issue per month. The same for MySQL. For NewSQL, as I have no experience with this database, I will have more issues because probably I will do a few more fuck-ups, okay? And the effort, 20 days for PaaS database, 25 for MySQL, 40 for NewSQL. And that's how you use metrics. So you have some particular problem to solve. Let's say it's voting for the presentation, right? And you have different solutions. And you check how every single solution applies to your metrics, and you choose the best one. So here, probably MySQL will be the best one because it destroys the architecture metrics in the lowest level, okay? Okay, so that's how it works in practice. If you have metrics describing your architecture, if you are choosing one particular solution, you just verify how this solution, how this task applies to the metrics, how it changes the metrics. And if you do that, you are really close to implementing the data-driven organization. If everything is described by numbers and you can measure those numbers, you can put them on some charts, on some dashboards, like on Grafana or something like this, then you can just take the technical as well as the business decisions based on the number and stop guessing. I'm not guessing that I need to change it. I know that last time I've changed something, it changed my conversion for 2%. So let's do the same right now. And it's still easier to talk to the business because they say, okay, we want to do some performance tuning. Yeah, refactoring one more time. I said, yes, but last time when we did this performance tuning, our conversion was changed by 20%. Okay, no problems, please do the refactoring. Because they see the value, because they see the data, and they know that we don't want to play with the technology because I've been on the Devoxx and someone say that, it's a great framework, you should adopt it. So I'm going to, on Monday to my work and I say, yeah, we need to adopt it because the guy on Devoxx said that it's great. No, there is a real data based on that. If you have such data, you can use those metrics for monitoring, okay? And what's the really important stuff here is that if you want to use the metric for the monitoring purposes, you need to think if you can measure the metric. Because we want to have a metric on user experience. Great. How can you measure the user experience? In a simple way. It's not so easy, okay? So if you are designing the metric, you need to think about how you can measure the metric. For example, we are measuring the user experience metrics based on the time needed to user and number of sessions taken by user to complete the onboarding to our system, okay? So if you create a trial on Devkiller, you need to do some onboarding steps, like invite a candidate, create a test, etc. And if person needs more than one session to complete the onboarding, it means that it's something terrible happening, because people are logging out from the application because they cannot do that. They cannot watch at what we expect, okay? So we need to change it. So every time when you want to use the metric for monitoring, please think about how you can measure it. Next thing, if you can monitor some particular metric, okay, Then you can go one step further and use those metrics for alerting. Because if I know that I have some metrics in my system, it can be business metric, it can be, I don't know, technical metric, doesn't matter. If you have any metric, and you know that the normal value of this metric is, let's say, 13, if it goes now to 20 or to 3, maybe there should be alert triggered. Okay? So I have some metric. Let's say that it's the number of users registered per hour. And I said that usually it was like 100 user registered. Now it's 10. So maybe there is some issue with the platform. And I should verify this issue. And I can automatically invoke the alert, okay, or trigger the alert. So I don't need to have any network operations center sitting 24/7 watching at the system state. No, I can automate it because I have metrics, and I can put the particular thresholds on the metric, and I can say, okay, so if this metric drops to 3, then it's a warning, and if it drops to 1, then it's a critical alert. You should, I don't know, contact the pager duty or the ops genie and call the person who is on duty just to wake up and fix it. And you can do it fully automatic way. Okay, so that's the basic idea. Then you go broader. So you create runbooks which describe how can you react if something happens. If you are familiar with if you are not familiar with the runbooks, you can go for the GitLab runbooks. They share the runbooks publicly, and there is information, for example, what you should do if the NFS service goes down, or if the, I don't know, Gluster FS system goes down. There is the description. The most important thing, don't panic. And then please check this one, check this one, check this one. If this command return true, then do this one. If it returns false, then do this one and this one. And the next step, if you can describe this procedure in a runbook, so why can't we describe it in the bash script? If I know that I need to invoke this method and this method and this method, and based on the result of this method invoke this or this one, then I can create a bash script that does the same. Okay, and that's what we are doing, for example, in our organization. We are just translating the runbooks we've created in Markdown to bash scripts that are triggered automatically if some problem occurs in the system. Okay, so that's what you can do. Oh, there is a problem with communicating with this service. Great, so maybe try to restart it. Fixed? Great. Not fixed? Then maybe you can do something else. You cannot, so trigger an incident, and the person on duty will solve it. And how it looks on a particular technical stuff, because it's not a problem to implement that. It's extremely simple. If you will start with those simple metrics and then go for a few more complex ones, then it's, for example, the technology stack that we used in our company, and it works really great. So the first thing is that for the metrics that we can measure on a daily basis from the application, so the technical metrics like a number of invocations, the total time of the service, number of errors, number of issues, number of some other problems, then we are using micrometer from Spring Boot that is triggering or sending the metrics to Prometheus. Prometheus is a data series database that works with something called the alert manager. So on Prometheus, there is alert manager that can continuously observe those metrics. And if any metric in some given time window exceeds some value, some threshold, then it can do anything you want because it's scriptable. So it can, for example, invoke some REST service. It can, I don't know, start a Jenkins job to do something, okay? It can trigger an ops genie or pager duty incident to wake up someone who is on duty to do something, etc. Okay? So that's what we use. Also use InfluxDB for the long-term storage, because Prometheus holds the metrics just for a particular time, like 2 weeks, so you can use it to operate on that. If you want to make some decisions based on the long-term storage, then you need, for example, InfluxDB. All the data can be shown on Grafana. Okay, so there are nice dashboards that everyone can log in, check how it works, etc. If you need some more data that is available in your transactional databases, you can, for example, use Redash, which can connect to any transactional database like MySQL, Oracle, or something like that, and you can build the dashboards based on this one. Okay. We also use New Relic to track the performance of our application, which is another kind of metrics. Okay. So as you can see, we have 3 kinds of metrics that we can apply to our architecture. First is this high-level architecture metrics like the total build time, number of collaborators, number of invocations, I don't know, the testability, right? So the number of bugs. So all those high-level architecture metrics. Then you have the technical metrics, like a number of the messages that are going to the dead letter queue, okay, etc., etc. Number of not delivered messages, number of rejected messages, number of retries on some particular REST invocation. And based on those metrics, you can fix your architecture, but you know what's the reason for fixing it. I want to change the circuit breaker I'm using, or I want to change the client-side load balancer from, I don't know, Ribbon to something else, because I have a lot of retries on my communication, like 10% of the requests are retried, and I want this number to be not more than 5%. So we need to rebuild our stuff, maybe change the load balancing policy, and see what's the difference. And I log in into Grafana, and after 2 hours, I see what was the difference. What was the impact of this change? I know it for sure. It's not just my guess that maybe if we'll change to, I don't know, response time weighted from round robin, then it will help. Maybe not, maybe yes, I don't know. Let's check it, but let's verify it with real numbers, okay? So that's the second kind of metrics. The third kind of metrics are the business metrics that you can also use to talk to business. Because if you see what's the relation between the architectural metrics, the technical metrics, and the business metrics, then you can announce or communicate the technical changes to the business using their language, using the business metrics values. Okay? So that's the most important stuff right here. And the most important takeaways for you is that the most important stuff when working with metrics is just writing down the requirements with scales. If you will write down requirements, you put the numbers on, then you completely avoid communication gaps, okay? There will be no communication gaps because we have written down what do we mean by resilience of our application. We know what are the numbers here. Okay, so everyone knows what resilience means in our context. Okay, if you describe the metrics, remember that you should start with the simplest metrics, so with the horse on the right, not the horse on the left. Okay, because it's really complex to write metrics that are really useful. Okay, and why do you need those simple metrics? Because if you have even the simple metrics, you can start working on that metrics when you are planning some architecture-related changes. So you are trying to change something. Okay, so now let's check how it applies to our application. What's the impact of the change that we are planning to do? What's the impact on the metrics? Okay? Because if you will create like 40 different metrics, then imagine that for any single task, you need to consider what's the impact for 40 metrics. It makes no sense. Usually, if you have 7 or 8 metrics, it's still enough to drive your architecture and not to create giant overhead of the metrics itself. And last but not least, start measuring those metrics, showing them on Grafana, and it's really extremely simple. So introducing the micrometer to Spring Boot application, exporting data to Grafana, it's probably like you can do it in 1 day. Okay? So it's not like you need to create a 6-month project to start doing that. It's that you need to have 1 or 2 days to start gathering the most important and the most required metrics in your organization. And that's all. Thank you very much. If you have any questions, then I will be here for a few more minutes. Thanks.